Hi, and welcome to this video on proving a trigonometric identity. And the identity we have right here shows us that there is a relationship between secant and cotangent. Let's prove this identity. And to prove an identity, we want to start with the most complicated side of the equation, and then use algebra and trigonometry to get to the simplest side of the equation, in this case, 2 cotangent squared of theta. So we start with 1 plus secant squared of theta over secant squared minus 1, and then take away 1. And we need to use some tools to eventually get to 2 cotangent squared of theta. Now, among basic trig identities, there isn't one that relates secant and cotangent directly, but there is one that relates secant and tangent. So we know that when we have 1 plus tangent squared of theta, we're talking about secant squared of theta. Then when we solve for tangent squared, we find that tangent squared can be written in terms of secant squared as 1 minus secant squared minus 1. So one thing we can say immediately is that the denominator of the first expression we have on the left-hand side of this identity is the same as tangent squared of theta. Now we can also say that the numerator can be written in terms of tangent squared of theta, because if tangent squared can be written in terms of secant squared, then also secant squared can be written in terms of tangent squared. We have here secant squared equals 1 plus tangent squared. When we add both, we add 1 of both sides of the equation, we get twice 1 plus tangent squared of theta equals 1 plus secant squared of theta. So we can replace the numerator of the first term on the left-hand side of the identity by 2 plus tangent squared of theta. So then we have 2 plus tangent squared of theta over tangent squared of theta. Then take away 1. And we're trying to get to cotangent squared of theta times 2. And once we get to this point, we notice that there's something in common between this term and that term, namely tangent squared. So let's split the fraction into 2 parts. We have 2 plus tangent squared of theta, all that over tangent squared. That's 2 over tangent squared of theta, and then plus tangent squared of theta over tangent squared of theta. And then take away 1. And then, because we're dividing tangent squared by tangent squared, we get a 1 there. Then take away 1. And 1 minus 1 is 0, so that part is going to disappear. While 2 over tangent squared can be rewritten as twice 1 over tangent squared. This way we can see there is definitely the 2 we want to see at the end of this problem showing up. We want to see 2 times cotangent squared of theta. Now we see the 2 separated from the rest, and the rest looks like 1 over tangent squared of theta at this point. So here we used, on top we used a plus b, all that over c is a over c plus b over c. And then we used a over b equals a aside, and then times 1 over b. And when we write 1 over tangent squared, we can think about that fraction as 1 squared over tangent squared. And it's good to think about the fraction that way, because then we get to see 1 over tangent of theta more clearly all that squared. Here we have used 1 over tangent squared of theta is one over tangent all that squared. As we can distribute the power between the numerator and the denominator. And something very nice that happens at this point is that we can replace 1 over tangent by cotangent, because cotangent is the reciprocal of tangent. So here we're talking about twice cotangent of theta squared, and that's exactly twice cotangent squared of theta. Square goes as a power of cotangent only, not theta, by notation. Here we used cotangent is the reciprocal of tangent, and here we used notation. Cotangent of theta, all that squared, is written as cotangent squared of theta. And that's the end of this problem. So if you have any questions, let me know. I'll be happy to help you. And there are more videos about trig identities and proving trig identities. Bye-bye.